diagram, we are given a diagram with a tangent to the tangent SO. So we are not yet told that is a what? That is a tangent, but we are given parallel lines SO and PN. First question says prove that PUNT is a PUNK is a cyclic quad. So if you check our diagram there, in order for you to prove that PUNKT is a cyclic quad, you need to know your rules for diameter. We are given the center and the diameter there. Then our diameter OT, if you check, it subtends a 90 degrees at K1. So therefore 10.3.1. So K1 is equals to what? 90 degrees. Angle subtended by a diameter. So we know that if you check our diameter OT again, it subtends a 90 degree at what? At U1. So U1 will be equals to 90 degrees. Angle subtends, same reason. We'll just write same reason. So if we check again, K2 plus K3 are equal to 90 degrees. Angles on a straight line. If we, because K1 there, it is what? K1 is 90 degrees. So if you do angles on a straight line, K1 plus K2 plus K3 is equals to what? 180. So because we want to prove Punk that it is a cyclic quad, so we are gonna transpose everything that is not K1 to the other side and make K2 plus K3 the subject of the formula. So if we continue there, you notice that K1 U1 is a cyclic quad. U1 is equals to 90. So and K2 plus K3 is equals to 90. So exterior angles of a cyclic quad. If K2 plus K3 are equal to 90 and U1 is equal to 90, meaning Punk is a cyclic quad because U1 is equal to what? Is equal to N is equal to U1 is equal to NKP, which is K2 plus K3. They are both equal to 90. Exterior, converse, exterior angle of a cyclic quad. Yeah, we've proven the first question. Prove that SO is a cyclic quad. SO is a tangent to KUST. So in order for us to prove that SO is a tangent, to the cyclic to KUST, we know that T1, you are given that T1 is equals to X. So if you remember on a previous video, that Z of us of like this is how you know that you are now dealing with a tangent. This angle is equal to this angle. So if that angle is equal to that angle, that's a tangent. So that's what we must prove here. So if you check them, you must prove that you must prove that O1 is equals to X. So if you check if you prove that O1 is equal to X, so if you use the bigger triangle TSO is equal to 180, sum of angles in a triangle So if you check the OS plus that whole angle, so when a radius meets with a tangent, it forms a 90 degrees. So we know that sorry, I've made a mistake. So S and O, just switch it off. So if you check that when a tangent meets with the radius, you might it subtends an angle of what, of 90 degrees. So if we look at triangle SOT, which is equal to 180, so we are given that we are what, plus O plus T 1 is equal to what, 180 degrees. So what we are proving here is that angle, we must prove that angle S1 is equal to x, so that we know that that thing is a tangent to the circle. So what we are going to do is saying O is equal to 180, because the tangents meet the radius at 90 degrees. You minus this 90, which you substituted as then minus x, which is T1, 90 minus x. So this is angle O. So after you found angle O, you know that if you check the angle besides u1, but not u2, not u2 and u3, but u1 will be equal to what, which is OUS is equal to 90. Reason is the reason is angles on a straight line, angles on a straight line, straight line. So if we check a triangle OUS, so we got S1, that's what we're required to prove that it is equal to x, which makes it that a tangent. So plus OUS plus the angle O, which is equal to what, 180 degrees. Sum of angles in a triangle, angles in a triangle. So S1 will be equal to 180. So this is 90 minus x, is the one that we calculated here, minus 90. So if this is a minus, meaning when you take it to the other side, it will be plus x. So this is also a 90, we've proven it, minus 90. So minus 90 makes this minus 180. So 180 minus 180 is 0. So therefore S1 is equal to x. Then SO is a tangent to KUST, because S1 is equal to T1, which is equal to x tangent. Prove that POST is a cyclic. So what you're going to do is you're going to construct a line, construct a line PO such that OPT is equal to 90 degrees. So we have constructed that. So if TPO is equal to 90 degrees, and proven or construction, and then TSO is equal to 90, tan perpendicular to radii. So therefore TO plus TSO is equal to so this is 90 degrees plus 90 degrees. Remember here we are proving, so we have a right to construct. You have to construct, so that's why we constructed what? PO. So this gives you what? 180 degrees. So opposite, therefore POST is a cyclic quad, is a cyclic quad. Opposite side angles of a cyclic quad add up to 180 degrees or are supplementary.